Okay, so if I can remember the number, I was going to plug it into my calculator. 1.5 times 10 to the negative 11. So negative log 1.5 times 10 to the negative 11th. So that is a pH of 10.82. Okay, so it is basic, 10.82. But then I need to subtract that from 14 because 10.82 plus the POH equals 14, and they're asking for POH. So that's 3.18. Yeah. That's the other thing. You can do that in your head a lot too. So it just makes it easier for me to... The alternate way you would do it, I'll do this in a different color, would be you use OH minus times H3O plus is equal to 1 times 10 to the negative 14th. And you solve for the OH minus, and then you say POH equals negative log of the OH minus. Okay, so I like the blue way, but you could do it the green way and get the right answer. Okay, so let's take a few minutes and let you guys go through these. The second one's pretty easy, and then the others, the last three, require 2 steps. And like I said, I'll write equations that I'm going to use in another minute or so, and then, you know, but ideally you guys just go up here and find the ones you need. Now, obviously, those equations are in the exam equation sheet, but you need to have a certain comfort level with which goes to which. Oh, that's not right. These 2-step ones where you use POH, that's when POH is most useful, is simply to get you via pH in an easier way. Okay? We don't use it for a whole lot more than that. I feel like I did too, and I just wrote the wrong number down. So I'll double check it in a second, but when you said that, I was like, that sounds familiar. Yeah, I typed in, yeah, it's 10, yeah, you're right, this is an 8. Okay, I don't know why it keeps coming up as 6.31. That's like some weird coincidence about the numbers that I picked initially. All right, so as you're finishing up, check these answers, see if you have any clarifications for me, if you're not getting the same one. There was one I messed up, so that's always possible. All right, so we'll continue to practice these. A lot of the times it's going to be, we're going to solve for, we're going to have a concentration of a weak acid and we need to know the pH. So we get the H3O plus and we find the pH. Or maybe you have an unknown solution, but you know the pH of it. You can work backwards, find the H3O plus, and that can help you determine what the acid is. Or on Friday, we're going to get to dealing with weak bases where we do ice tables. That'll give you the OH minus. So you need to be able to track back to the pH as well. Like I said, pH is the scale that we're most comfortable using, and so we will routinely work back towards pH or have to start with it and work to a concentration. Okay? So we'll keep doing these as part of that. If you remember, we did a weak acid calculation pretty early on, beginning of last class, or kind of end of the previous one. So we did this HClO2 and found the hydronium ion concentration. So as a reminder, we had 0.75 molar of that weak acid, and then we found out that only 0.085 molar was produced for the H3O plus. So we started out like this, 0 of the product, reactant, and then we just made a smidge of the product. Lots and lots of reactant left over. For strong acids, we don't even really do an ice table. Like I did it here to show you that all of it gets consumed. It's not a minus X because we know all of it gets consumed. It's not a smaller amount. You can also think of this as stoichiometry. Like if I have 0.75 molar HNO3 and I have this reaction, for every 1 mole of HNO3, I make 1 mole of H3O plus. Okay, so that would be 0.75 molar H3O plus. So stoichiometry works for reactions that go to completion, that are very, very big Ks. When you have a K that is not reacting completely, that's when you have to do the more complicated stoichiometry, which is what an ice table is. but you have to do an ice table. If you've got a strong acid or strong base, you don't need to bother. Whatever the original amount of the acid was, that's how much H3O plus you're going to have. Okay? All right, so let's do some more of those today. We're going to kind of make sure we're really comfortable with doing weak acid calculations. So I want you to start with this one, or I guess any acid calculations. I want you to start with this one. Oh, I just remembered something I was going to check on your homework before I tell you something. So I'll do that while you're doing this. So go ahead and take, this one shouldn't take too long. That's a hint. And we'll talk about this one and then move forward. Don't judge me for eating in front of you. I forgot to have a snack and I worked out really hard this morning. Okay, hopefully you heard me when I said if it's a strong acid, that's the concentration of the H3O plus. You don't need to do anything else. Now, you make sure that you know what the 6 strong acids are. There's a list. Check your list, make sure that it's one of those, and then you just go for it. Then the pH is the negative log of this. Or 0.64. Obviously on this one, they kind of gave you a hint, right? They said the K is much, much greater than 1. They're telling you it's a strong acid. That's not always going to be there necessarily. Of course, if it was just this and it didn't say that, and you're like, where's the K? I don't know how to do the ice table. That's also a hint. They don't need to give you the K. It's strong. All right, let's do another one where we're doing a weak acid now. Again, determining H3O plus and the pH. Okay, here's your big hint. This is a very small k, so we get to ignore that minus x. All right, if you didn't notice that, you're probably in the middle of doing the quadratic equation and kicking yourself. Okay, so make that approximation, makes it lots more doable. So these really should be no different than a chapter 16 problem, right, from the last test, because it's still just an equilibrium. In fact, it's easier because the coefficients are 1. So you find the H3O plus, that's what X is here, and then you just take the negative log of that to find the pH. All right, any clarifications on this? Points that I did that you're like, what were you doing there? So we will start doing in chapter 18, we're going to do buffers, which is where you have a combination of a weak acid and its conjugate base. So we'll actually start with a concentration up here as well. So you'll end up with some number plus x there. Now in this instance, you could get rid of the plus x and the minus x, but sometimes you might not be able to. Anyway, that's when it'll get a little bit more complicated. So these ice tables start to feel like, why am I writing the exact same ice table every time? I know it's x squared over the concentration minus x. Just stick with it for a little bit longer, because on Monday when we start 18, we make them more complicated, so we need to like maintain this routine of the ice table. Okay? All right, the next one's a little bit, I'll leave this up if you're still looking at it, but the next one's a little bit different. You have different information, you're finding a different thing. You're actually determining the K here. So approach it the exact same way, write out an ice table, put any information you know, and then see if you can, deduce what it is that how you're going to connect this to solve for the K. All right? Okay, ignore what I'm doing on the thing now. I'm just checking one of your homework problems. So when you're doing this, I would recommend that you just write one of these like generic reactions. So HA can represent any acid, and then A minus represents the conjugate base. So think, you know, the one we did before was HClO. So HA is HClO, A minus is ClO minus, okay? You can just write acid plus water if you want, makes the conjugate base and H3O plus, but this is how you'll see it, you know, in the book and stuff. Okay, so you hit this point, you've done the ice table, you've plugged it into the K expression, and then you're like, what? What can I do with this? That additional piece of information, the equilibrium, or at equilibrium, the H3O plus equals 5.6 times 10 to the negative fifth. They gave you the equilibrium concentration of the hydronium ion, 5.6 times 10 to the negative fifth. That's X. So they're telling you what X is. So now you have this Ka in terms of X. You can just go plug that value in for all of those X values, because X is equal to X, right? Doesn't matter which X it is. And then you can solve for the Ka. So it's still using the same general approach. It's just taking away one piece of information, giving you another, kind of tweaking the problem a little bit. The other way they could have phrased this is giving you the pH. So let me just see what that would be. So the pH for this would be 4.25. So they could have said at equilibrium, the pH is 4.25. That would be a little bit harder, because then you would have to work backwards and say, oh, if the pH is this, I can calculate the H3O plus, and I know that's equal to X. Okay? 5.6 times 10 to the negative fifth squared over 0.1 minus 5.6 times 10 to the negative fifth. So this comes out to be 3.14 times 10 to the negative eighth. So that's the K for this reaction. I was debating on the next question what I wanted to do based on, I think I just need to do it the same way I did it in my other classes, and then decide if I'm going to take these problems off the homework or not, so that there's consistency at least. We're going to do the next one together. It's a combination of acids. You just leave it here for another minute. Make sure everyone's caught up. Sorry, ignore that blue down here. That was me. Messing around trying to do one of your homework problems. Okay, so combination of acids. Let me just say, and if I need to clarify this with the other classes, I will. But when you have a combination of acids, the strongest, not a strong one necessarily, but the strongest one will dominate. So the acid with the largest K is the only one that matters. Now, like I said, I may go in and remove these questions from the homework anyways because the book presents it a little bit different. But when you look at this question, there's 0.25 molar of that weak acid and 0.1 molar of the strong acid. So they give you the K here, 1.8 times 10 to the negative fourth, and then we know that this one is big, right? So really what we're saying is that the pH is going to be completely dependent on that strong acid, okay? Yes, the weak acid will contribute a little bit of H3O plus to the solution, but not enough to change the pH significantly. So we literally would just go H3O plus equals 0.1 molar, and then the pH is the negative log of that, or 1. Now, I worked through this with my other classes. I'm not going to do it in here because I just decided it's not essential. But if you go ahead and take the weak acid and you calculate out all of its concentration changes, it changes the pH by it drops it by 0.01. So instead of 1.00, it ends up 0.99 or something. So it's very insignificant, the contribution of that other acid. Now, if they were closer together, like 10 to the negative fourth and 10 to the negative fifth, like two different weak acids, then we probably would have to calculate one and calculate the other and then add them together. Okay? So for the sake of doing that, I'm just going to leave it for next class because I don't want to mess up where we're at and where the other class was. So what I'll do is I'll bring in a sample problem that has two weak acids for the beginning of next class, or I'll just take them off the homework, but I'll decide by that point. Okay? So for now, just assume whichever is the largest K, that's the only one that's going to affect the pH. And we're going to stop there. So please, if you haven't yet, get started on the homework. You've got to practice little by little. It's not going to help if you're, doing it or having ChatGPT do it. It's not going to help if you do it that last minute. You got to consistently be practicing this stuff.
If I went in at 2. 2? You got me psyched dinner. Is it okay if I go up a little bit earlier, or do you want me to wait till 12?
No, let's go.
Okay, that's fine. I just want to make sure with you.
Yeah, no, that's good. Besides, apparently I had my snack in the middle of class anyway.
Oh, no, it's okay.
I just